In the previous video, we learned how to group our model into subsystems and how to implement the proper naming convention for these subsystems. In this video, we will learn how to set up the communication between our subsystems. To exchange signals between the different subsystems of the model, we must add op-com blocks. These can be found in the RT-Lab library. It is mandatory that the subsystem's inputs go through an op-com block before any operation is performed on the signals. For example, on the left, this is an incorrect implementation because we add a constant value to our signal before it enters the op-com block. On the right, we have a proper implementation where the input signal is routed through an op-com block before being routed to any other block. Afterwards, we can manipulate it. Following the same logic, we cannot use goTo and from blocks from Simulink between two subsystems because the signals would bypass the op-com blocks. It is important to add the op-com block only after having created and properly named the subsystems. These blocks can accept multiple inputs, each of which can either be scalars or vectors. Furthermore, there are two main categories of communication: synchronous and asynchronous. Synchronous communication is used between CPU cores on a simulator. This occurs at high speeds and allows real-time simulation. Asynchronous communication is used for communication between the target and the host. It is relatively low speed and thus not reliable for real-time simulation. It is important to make this distinction because we cannot mix synchronous signals or asynchronous signals in one op-com block. In the console subsystem, one op-com block is enough in most cases. However, we can use up to 25 of them to receive signals from the real-time subsystems. The use of multiple op-com blocks will define a unique acquisition group for each block, each with its own data acquisition parameters. Let's look at a few examples. In this example, we have two subsystems, a computation subsystem and a GUI subsystem. We can see here that two op-com blocks are used to send asynchronous signals in between these two subsystems. In this example, we can see an implementation of multiple computation subsystems. These computation subsystems do not communicate with each other, and there are only asynchronous signals between the three subsystems. Therefore, we only require one op-com block per subsystem. In this example, even though we use both asynchronous and synchronous signals, we only have one op-com block per subsystem. This is because the inputs to each subsystem are either synchronous or asynchronous, but not both. In this final and more complex example, we see that there are multiple blocks per subsystem because there are different types of signals entering each block. We have both asynchronous and synchronous signals. Therefore, we must use the appropriate number of op-com blocks for the number of different types of signals entering each subsystem.